Good afternoon, class. Thank you. You can sit down. All right, in today's lesson, we are going to just look at the correction of the homework, which was on solid trig. Okay, next lesson, because we've completed the topic on trig, I'm going to give you a test, a revision test. And before we do the next topic, which is going to be on social maths. Okay, I have put you into groups. We're starting with question 2. Gabriel's group, you are working on question 2, so you come and explain question 2 on the board, please.
Figure 39.9 shows a pyramid on a base of side 8 centimeters. The altitude of the pyramid is 12 centimeters. A. Calculate EF. EF is the perpendicular height of the base pyramid, so it is half of 8 centimeters. So EF equals to 4 centimeters. B is draw the triangle VEF adding the known dimensions. So VEF, since we drew it, the dimensions are 12 and 4.
Question C reads, find the angle VEF. To find angle VEF, we use tan. So tan theta equals opposite on adjacent, which is equal. Therefore, tan theta is equal to 71.6 degrees. Question D reads, calculate the slant height VE. We use Pythagoras theorem to find the slant height. So VE is equal to square root of 12 squared plus 4 squared. And that's the square root of 160. Therefore, VE is equal to 12.65 centimeters.
People are really smart.
Question 2D reads, E reads, calculate the area of triangle VAD. VAD. Area equals half times base times height. The base of the triangle is 8 centimeter because of the square base. And the height equals 12.65, which is also the slant height, B. Half times 8 times 12.65 equals 50.6 square centimeters. And the total question, the complete surface area of the pyramid is 4 times 50.6 because of the 4 triangle surface areas plus the base area, which is 8 times 8. It is equals to 202.4 plus 64. Total surface area of the pyramid is 266.4 square centimeters.
Okay, well done, Gabriel and his group. Diagram is very clear, and the working out is also very, very clear. Next one, the group that is working on question 3, I think it's Vui and his group.
Question 3 reads, Figure 39.10 shows a pyramid on a rectangle base. Calculate the length VA. To find the length VA, firstly we find the length AC. We use the Pythagoras theorem. AC squared equals square root of DC squared plus DA squared, which is 10 squared plus 8 squared, which is 164. The square root of that is 12.8. Therefore, it's the diagonal, therefore we divide it by 2, we got 12.8, which is the length of AE. So VE squared plus AE squared equals VA squared. 11 squared plus 6.4 squared, which is the half of length AC, equals 161.96. The square root of that is 12.7 centimeters to 1 decimal place, which is the length of VA.
That's all. Thank you, Vui. Well done. Number 4, Lester.
Figure 39.11 shows a pyramid on a square base with VA equals VB equals VC.
Pointer. There.
Figure 39.11 shows a pyramid on a square base with VA equals VB, VA equals VB equals VC and equals VD equals 5 centimeter. So the question is calculate the altitude of the pyramid. It's VE. So first I find AC. I use Pythagoras theorem. So AB square plus BC square equals AC square. Square root of AC equals square root of 3 square plus 3 square, which is equals to square root 9 plus 9 equals root 18, which is equals to 4.2 centimeter. AC equals 4.2. Okay, then I have it. 4.2 divided 2 equals 2.1 centimeter. It's to 1 decimal place. CE equals 2.1 centimeter. To find VE, I use Pythagoras theorem. VE equals square root of VC square equals CE square plus VE square. So VC equals 5 square equals CE, which is 2.1 square plus 1 square on both sides. So 5 square minus 2.1 square, which is equals to root 25 minus 4.41 square, 4.41 equals root 20.59, which is equals to 4.5 centimeter.
Good. Well done, Lester, and your group. All right, question 5 is George and his mobs. For them to use.
Figure 39.12 shows a wooden edge. Find the length EA and the angle Q. The end faces ADF. And EBC are isosceles triangles.
Oh, sorry.
Okay, to find EA, we have to find B first. B square equals to 6 square plus 4 square equals to 52, which B is square root of 52, which is equal to 7.21 centimeters. Okay, from there we get BE, and we work out EA. EA square equals to 12 square plus 7.2 square equals to 195.9841. EA equals to the square root of 195.9841 equals to 14 centimeters. One decimal place. Okay, to find angle Q, angle Q equals to sin Q equals to 6, which is the opposite, this one, and 14, which is the hypotenuse, which is equal to 0.428571428, which sin Q is equal to 25.3 degrees.
Okay, it's angle Q, which is equal to 25.38 degrees. Well done, George. Next group to do question 6. Natasha.
The base of a triangle prism shown in figure 39.13 is a triangle 8 centimeters and 6 centimeters wide. The vertical faces ABC and PQR are equilateral triangles of side 6 centimeter. Calculate A, the angle between diagonals PB and PC, which is this angle. To find the angle, you have to split it in half, so it will be 2 right angles. Yeah. Firstly, you have to find PC, so you use Pythagoras theorem on the triangle PCR, which is 6 squared plus 8 squared, which is 100. The square root of 100 is 10. And this bisects this in half, so it's 3. So use the sine ratio opposite over the hypotenuse, which is 3 divided by 10 equals to 17.46 times 2, which would give 34.92 degrees. For B, the angle between the plane PBC and the base. So it's this. I label this point here as E. So you find the angle PEF.
Very good.
To find PE, you find the find Pythagoras theorem for the angle. For triangle PEC, which is 10 squared plus 9 squared. Here. PE, 10 squared plus 3 squared is equals to 9.5, which is PE. Then you use cosine 8, which is the same as CR, 8 over 9.5, which is 33 degrees. For C, the angle between the diagonal PC and the base, which is this angle C. Firstly, you have to find PF. Use the triangle PFR for Pythagoras theorem 6 squared plus
Minus 3 squared.
3 squared, which is equals to, the square root of that is 5.9196. Then you use sine opposite over hypotenuse divided by 10 and 31.31.
Okay, this is a good question because it covers most of what we've learned. It asks you to find the angles between two lines, the angles between two planes, and also a plane and a line. Because part B there says find the angle between the plane PBC and the base, which are two planes. And it's something that I found that students don't do very well. So Natasha has done a very good job of doing that question. Okay. Just one important note that I keep repeating all the time. Sine theta is equal to 3 on 10. And you are saying equals 17.46 times 2. No. Okay, theta is equal to 17.46 and the required angle is 17.46 times 2, which is 34.92. Make sure you state that correctly, especially if you are doing a test. I will not give you any mark if you are telling me this. All right, the same applies to this one because it's an angle that you are talking about. Sorry, it's theta and not Q, and also this. Okay, the rest of the question is done very, very well. Okay, now if you haven't done this work, make sure you do question 6 because it covers a lot of what we are talking about here. Okay, to question 7. Who's doing question 7? You haven't finished yet. Okay, question 8 finished? Come.
Question 8 reads, figure 39.15 shows a shed with a slanting roof ABCD. The rectangular base ABEF rests on level ground and the shed has 3 vertical sides. We asked to calculate the angle of inclination of the roof to the ground. So the angle is the angle between the plane ABCD and the base ABEF. So we use cos theta is equals to 16 over 34 because these two triangles are equal. So theta is equals to 61.9 degrees to 1 decimal point. And we asked to find the volume of the shed in cubic meters. First, we need to find the height CE. So CE is equals to 34, we used the Pythagoras theorem, 34 squared minus 16 squared. We came up with CE is equals to 30 meters. So to find the volume, you find the area of the cross-section multiplied by the length. So half base times height multiplied by the length. So it's half multiplied by 16 multiplied by 30 multiplied by 15 equals 12,000 cubic meters.
Sorry. Thank you very much, Raylene. Well done. We're now on question 9. Garonamo.
Question 9 reads, the base of a pyramid consists of a regular hexagon ABCDEF of side 4 cm. The vertex of the pyramid is V, and VA is equals to VB, which is equals to VC, which is equals to VD, which is equals to VE, which is equals to VF, which is equals to 7, which is this length here. Okay.
Oh, she had to draw the diagram.
The question, we are asked to find the angle P between VA and the base, which is this angle here. So to find the angle P, we use cos theta, which is equals to 4/7, which is equals to 55.15 degrees. And question B reads, the angle Q between the face VCD and the base, So to get the angle Q, first we have to find the height, which is from this midpoint CD to V. To get the height of this, we get 4 squared, the square root of 4 squared minus 2 squared, the square root of 7 squared minus 2 squared, which is equals to 6.7. And to get this height, length, we get the square root of 4 squared minus 2 squared, which is equals to 3.46. So to get this angle, we get cos theta, which is equals to 3.46 over 6.7, which will give us 58.9 degrees.
Okay, good. And the same mistake you made. Okay, just make sure of that. Okay, this they've done very well because they had to draw the diagram themselves and then make sure it's the correct one, and then done the correct, given us the correct answers. So well done, Garonamo. All right, we are on to number 10. Hekoi.
Question 10 reads, in figure 39.16, ABCD represents part of a hillside. A line of greatest slope, AB, is inclined at 36 degrees to the horizontal AE and runs due north from A. The 36-degree angle is here. If I place the marker here, then this line AB, would be here, B would be here, and this line would run north to that. So it would be this angle here to be 36 degrees, but because the diagram is drawn like that, the 36-degree angle is there. The line AC bears 50 degrees, and C is 2,500 meters east of B. So the distance from there to there is 2,500 meters. The lines BE and CF are vertical. The lines BE and CF are vertical. For A, we are asked to calculate the height of C above A. Before we find C, we have to find the line AE. Therefore, we use the turn ratio. Turn 50 degrees equals 2,500. This length here is the same as EF. So 2,500 over AE, which is equals to 2,500 over turn 50 degrees, which is equals to 2,000, and 97.75. So to find CF, we use tan 36 degrees equals CF over 2997.75, which is equals to 1,524 meters to the nearest whole number. B, we asked to calculate the angle between AB and AC. So we use this angle here, sine 36 degrees equals 1,524 over AB. AB, which is equals to 2,592.95. So to find this, we asked to find this angle here, so we use tan theta, which is equals to 2,500 over this length here, which is the same as this, which is 2,592.95. So angle theta is equals to 43.95 degrees.
Good. Okay, the rest of you have to make sure you get these questions correct as well. Hopefully you've tried all of them and you understand the answers. All right, question 7, are we ready now? Okay, good. Come.
Figure 39.14 represents a wooden block in the shape of a triangular prism in which the edges AD, BE, and CF are equal, and the vertical and the bases DEF is horizontal. AB is equals to CB, which is equals to DE, equals to EF, which is equals to 14 centimeter. And the triangle angle ABC is equals to 40 degrees, and DEF is equals to 40 degrees also. The points G and H are the edges AB and BC, respectively. BG is equals to BH, which is equals to 4 centimeter. DG is equals to FH, which is equals to 20 centimeter. Question A, let's calculate the length of BE. BE. So to find BE, we use the right angle CF, which is also equals to BE. CH is equals to 10 centimeters, which we got from 4 centimeters BH minus from 14, which equals to 10. The hypotenuse is 20 centimeters, so to find CF, we use root of 20 square minus 10 square, which is equals to 300. Root of 300 is equals to 14.3, which is CF, which is also equals to BE. B, it says to calculate the angle between FH and the base DEF. To find the angle between FH and the base DEF, which is this angle theta. To find the angle, we use the same right angle triangle, CHF. The hypotenuse is 20 and the base is 10. So we use cos, because this is the adjacent. So cos 10 on 20 is equals to theta 0.5, which is equals to 60 degrees. 60 degrees here, which is alternate of theta here, so it's this angle is 60 degrees.
Theta is 1.5, theta is 60 degrees.
What he asks us to find the angle between the plane GHDF and the plane DEF. So that would be this angle over here. So in order to find this angle, we
There's a
find
marker there. Do you want to use a marker? Give me a bigger one. That one there.
so find this angle over here. So then, because this is 40 and this is an isosceles triangle, this should be 70 degrees. And over here, the line that we formed from here to here will be x, and this should be 90 degrees, but sorry, our diagram's not really that well, so anyway, this is 90 degrees. So then we use the sine ratio, sine 70 degrees is equal to x on this is 10, 14 minus 4 is equal to 10, which is x should be equal to 9.4 centimeters. So then we drew another line coming down this way. That should be equal to 17.3 centimeters because it's also equal to ADBE, which is 17.3 centimeters. So we also drew another line from here to here, and that forms the angle we're trying to find over here. So this is 9.4 centimeters, and this is 17.3. So because this is not a complete right angle triangle, we draw the hypotenuse line coming down this way. So we find the hypotenuse. So 9.4 squared plus 17.3 squared is equal to 19.7. That's this one here. And then to find this angle here, we use cosine 9.4 on 19.7, which is equal to 0.477. Shift it, and you get 61.5 degrees.
Good one.
Patty is asking us to find the distance between the midpoint of GH and DF.
It's the most difficult question.
So the midpoint from GH and DF is from ear to ear, which is just the same as the hypotenuse. The hypotenuse. So 9.4, the square root of 9.4 plus 17.3 is equals to 19.7, which is just the same as the hypotenuse, 19.7.
Well done. Okay, I've actually never asked the students to explain this on the board. I had to try and do it myself if they had questions, and I'm really, really proud of all of you for doing this exceptionally well. Okay, thank you very much. I'm probably fortunate to teach a class like you. Anyway, sometimes the keyword to the pilot teacher is 3D. All right, good afternoon, class. Thank you.